Hi everybody, welcome to my talk about CQRS and modern Java. My name is Simon Martinelli, I'm from Switzerland. You can reach me on martinelli.ch or on Twitter. I work as a freelance consultant in Switzerland for around 15 years. And I'm also active in the Java community. I'm the organizer of Java user group in Bern, so if you're Bern, join my Java user group. And I'm teaching at 2 universities. I'm a Java champion and a Vadin champion. So before we start, you can ask questions. So please ask questions during the talk. I will try to answer them. Or if you prefer to write your questions, you can go to slido.com with JCon 2024 and you can add your questions in the chat. And I will have a look at them at the end of my talk and try to answer your questions. So what's my talk about? My talk is about client-server communication. Why do I do that talk? Because I'm currently working in a project. We use different technologies, but we also have an Angular client and a Spring Boot backend. And as of these days, usually if you create an API, people tend to use REST or a RESTful way to do APIs. And I don't want to say that REST is not an appropriate solution, but I would say that REST is a bit annoying if you're doing client-server communication because you have resources and HTTP verbs and not methods. And in fact, what you want to do is you want to call a method on the server, right? And this led us to the problem that we had, that the API was nice, it was documented with OpenAPI, we can generate the client, but it has no semantics. So it just has like get method to get some data, but we don't know exactly what happens there. And so as I was looking for a better solution, there is a pattern called backend for frontend. Maybe you have heard about that. And I was digging a bit deeper and suddenly I saw CQRS. I know CQRS for many years. I will tell you what exactly that is. And I thought, hey, why don't we use something like that to have a better semantic on our REST API, especially also better performance, but we will have a look at that later on. So what's the problem with that? By the way, my talk is not about AI, but I thought, hey, AI must have some place in my talk. And I thought, oh, I'm talking about a waterfall. Why not ask DALL-E to create a waterfall? And I think the picture turned out very nicely. So this is my AI part of the talk. So now it's done with AI. But I want to talk about this waterfall. Maybe you know that. If you use, for example, Quarkus or Spring Boot, you usually have kind of a REST controller or a REST resource. And there you usually have DTOs because you want to abstract the DTO model from the entity model. But what in fact happens is that there is a mapper in between, like Mapstruct or Model Mapper. And what is often happening is that you just have more or less a one-to-one copy of the entity model in the DTO layer. And then you use one of these mappers and it maps one-to-one by naming convention to the DTOs. So you don't win anything or gain anything from that. It's just a copy of that. And then you have an entity. The entity is used by a service that does some business logic maybe, or the entity does the business logic. And finally, you have kind of a repository that saves the data to the database. So that's when everything comes in. If you want to get the data, more or less the same thing happens. Somehow you call a REST controller, a get method, for example. And then a service is called, the service calls a repository returns an entity, the mapper maps the entity to the DTO, and that's it, right? Sounds familiar? And I've created kind of a small example application. It's on GitHub, by the way. So let's get back to that. Here you find my code. It's on GitHub. CMAS.ch is my GitHub user, and CQRS meets modern Java is the project. And you find all the example code that I'm using right there. So in this project, you will see 2 folders. One is called CQRS. That's what I will talk about. And I also created a traditional one. And the traditional one has layers. So I choose to have layers. Doesn't really matter in my case I have an API and these repositories and so on. And here you see that I don't have a service layer because I thought this would be kind of an over-engineering just for the small demo. But the order controller uses the repositories. So we have a get mapping or a post mapping. Let's begin with that. We have a DTO, it's called purchase order. The purchase order has a customer DTO and a list of order item DTOs. And the order item DTOs, they have an ID, quantity, and the product DTO. So we have a nested structure that we send back and forth on our REST controller. So here in that case, we get just this purchase order DTO from the REST call, and then we use, in my case, I use model mapper. Most of the time I use map struct because it's more powerful, but here for the demo I just use model mapper and map this purchase order DTO to my purchase order. And the purchase order is more or less the same as the DTO structure, but it's a Java Persistence API entity, and this will store it, in my case, to an H2 database. So no, I think it's a Postgres database, but that really doesn't matter. So we have like a post, we also have a pot, and here in the pot I do the same. So it does more or less the same, except that it will just do an update instead of an insert, but I send all the data in this pot request, and finally I want to get these purchase orders. So I need, I can filter by first name, last name. I have introduced paging, and then I have repositories that has a very long finder method, and finally I map the result with the model mapper to a DTO, right? So that's more or less common sense. Who does application REST APIs like this? A lot of people. Okay, now let's see what happens. So my application runs, here the traditional one, and then I created some IntelliJ HTTP requests to get that. So here I have a call to the orders REST endpoint with the first name and the last name, so I pass there some wildcards because I want to have everything. And here, just for the sake of the demo, the page size is 9,999. That's probably way too much, so we don't need usually that amount of data. But now let's have a look what happens when I click there. It runs, but it takes 3 seconds. Why does this take 3 seconds? Any ideas? Just a hint, I use Hibernate and JBA for the persistence layer. We have a classic n+1 select problem. And if we look at the console, we see here many SQL statements, right? So why does this happen? The reason is the purchase order has order items. They are lazy loaded, and the order item has a product that is also lazy loaded. So we have a 2-level n+1 select problem in my case. The bad thing about that is that Spring Boot with, I think, Spring Boot 2.7 something decided to enable this so-called open session view pattern by default. So that means, in fact, when we read that, the transaction is closed after we get that. So the object mapper is accessing lazy loaded dependencies. This would usually fail. So you would get a lazy loading initial or lazy initialization exception. But we don't get that because Spring Boot has this open session in view pattern that in fact opens a new transaction and reloads the data. So that's an anti-pattern. Because between the 2 loads or the 2 transactions, you could have changes in the database and you would load inconsistent data at the end, right? So you should turn that off. Then you would have a problem here. So that's the problem from the traditional approach. So let's have a look at the issues that I think are problematic in that scenario. First of all, we have an issue, I call it too much. So that's what we saw before. First of all, we are loading data that is probably not necessary. We load everything just in the request. We even do that if, for example, we just need some parts of our purchase order, or just the amount of the order item and the article number, for example, but we load everything. That's when we load stuff. But in my opinion, it's even worse if you change data in that approach, because you send everything back to the server, and in fact the client could change any attribute of the structure. So you have to have logic on the server side to prevent changes on the data that are not allowed, right? So this is the other one, other problem that we may have. But on the same point, we also have an issue where we do too little. So we also often, when we read data, we do something I call underfetching. That means we have to have multiple requests to get the data from the server. And this results in the same issue that we've seen before that Hibernate is creating. If you have lazy loaded relationships, it will create an n+1 select problem. But this time on the client, not on the server. So this is even worse because you have latency over the network, and this will impact your performance. And on the other hand, we may have something called understoring. We want to store something in one business transaction, but because we do remote communication, we don't have like a distributed transaction on that side, and it could be that we change it, the first request something, and the second request does not work. So we have something, or we need something like compensating transactions to undo what we did just before. So that are the issues from that approach. So my idea is to use CQRS for that. CQRS stands for Query Responsibility Segregation, and is introduced by Greg Young. I think the first who wrote about that was Martin Fowler, like, let's say 10 to 15 years ago. But it was originally motivated by CQS from Bertram Meyer, who was creating the Eiffel programming language, and said a method can only be a command or a query. We don't want to have methods that are fetching data and changing data at the same time. But here CQRS is a pattern that usually is, or you hear usually about CQRS in combination with event stores, for example, or event-driven architecture. But here I use CQRS in the most simple form. So even if you read a document from Greg Young, it has like several stages in CQRS how you can implement that. And I just use the separation of command and query to achieve a better performant or a better secure, or an application that is better understandable finally. So how can we do that? For example, we can introduce a command that's called add item. So we can create like an order, and then we add items, and then we have something in the cloud there. It's called command handler. That could be literally everything. We will focus on that. I will show you how you can implement command handler with modern Java. And on the lower side, we have a query. It's called find orders, and there we have kind of a query handler that is fetching the data from the database. And here you see that we use the same database. So CQRS doesn't mean that you have to split the command and the query database. That's just another stage in adapting CQRS, but doesn't mean that you have to go full in if you just want to use the concepts about that. So if you have a look at modern Java, I will introduce some of the features. I would say most of you already know about that. And the first I like to introduce is records. So records were introduced in Java 14 as a preview, and finally or finalized in Java 16. And records are an immutable data structure. And because they are immutable, they match perfectly fine our concept of CQRS, because a command is immutable and also the result of a query is immutable, right? So that's a perfect match for that. And you can remove your Lombok dependency if you use that just to have immutable data. So there are some problems with that. So for example, if you have a immutable collection as an attribute in the record, this will become mutable. But we have just a simple add item command. And as you can see here, we just send the minimal data that we really need for the command. So we have the order ID that we know for which order we want to add an item. We need the product ID and the quantity, and that's it. So no more data is sent over that. Maybe just a few words about the difference between commands and events, because CQRS is often used in combination with event store. The difference between commands and events is very simple. A command is a request to do something. So the command handler in that case could just say, no, I don't execute the command, and reject it. Whereas an event is something that already happened. So that means the command has the name add item, for example, and if this succeeds, we could create an event, and the event would be called item added event, for example. So the events are always in the past form, right? So that's the first thing. Then I introduced some other concepts because just for fun, we have sealed classes. Who is using sealed classes, by the way, already? I had a hard time to find use cases for sealed classes. I found them I do Java development, I do also web development with Java. I use a framework called Vadin, and their sealed classes work fine because we often have like a component structure and I can define which one is allowed to be a subclass. But other than that, it was very hard. And as you can see here also from the example, I have a shape that permits a circle, a rectangle, and a square. So that's a very trivial use case, but probably not that useful at all. But we will see why these sealed classes are interesting. Then something else that I really like is the switch expression compared to the switch statement. This can yield a result. Here we see that we can do a switch over probably that's an enum, and then directly return the result. We don't have to use breaks or something, so I would never use switch statements probably anymore, just maybe in special cases. But that's not all. It becomes very interesting if we combine these new features. So Java introduced in Java 17 something called pattern matching. So pattern matching were introduced in Java 17 as the final version on the instance of operator. So you don't have to cast, for example, after an instance of. Or with Java 21, you can also use that in the switch expression. And here I can switch the shape, and that's why I use a sealed class, because then I need to consume all subclasses from this shape in my switch. And here I can directly, for example, use a reference to circle, the C there, or to the rectangle, and do things with that. So that's the point. And the switch expression must cover all passes, otherwise I get a compilation error if I don't do that. So that's why I choose that. And it goes even further, because with Java 21 we now also have so-called record patterns. That mean we can kind of destruct a record to its element and directly use them, and we don't need to reference the attributes on the record anymore. So that's what I use, and maybe we can have a look at how this is implemented. This is just an example, right? I just wanted to highlight the various Java features, and that's why we have an interface, a sealed interface order command, and this order command here has three types. We have a create order, another add order item, and an update quantity. When we have a look at these three commands, we also see a slightly difference between the REST style with the resources and the command model, because here we do fine-grained commands. So if you look at the UI, so if we have a UI that supports that command, we usually see something like a wizard, where the user starts to enter information, then it goes to the next step, and each step will issue a command that finally could issue an event, if you want to use that. And that's why I also did it like that. And I also use bean validation here, just to give an idea that we also can, for example, directly validate the commands. And the command handler is using the switch expression. So I already know that all the possible command cases are covered here in that case, and they use this order command like a namespace just for the commands that belong to the order command, so it's easy to read. So that's the purpose of this code. And here we see also the deconstruction of the add order item, for example, and I can directly use order ID, product ID, and quantity. So that's all for CQRS. As I said, you could now use a service, the service issues an event, and then do event storing, but we don't do that here. Now the question is, how do we access the database in that model? Maybe we should go back to the slides, and I like to introduce another tool. It's called jOOQ or jOOQ. Whoever heard about that? Not so many. So who knows Query DSL? Who knows Criteria API from JPA? Okay, more or less everybody's covered. So the idea of jOOQ is to have SQL directly in your Java application. Maybe there are people in my age here in the audience, and they may heard of something called embedded SQL. It was an idea of IBM and Oracle back, like, I would say 20, 25 years, 25 probably. And the idea was to embed the SQL statements inside your Java code, so you had kind of a precompiler that was using the SQL statements in the code and was generating JDBC code at the end. So that was the idea. It no longer exists for some reasons, but jOOQ tries to do something similar. So jOOQ has two parts. You have a domain-specific language, and that's SQL. So it's just SQL in Java. Do we have .NET developers here? Not a lot. They know LINQ, language integrated query. That's better. Or it's better from the conceptual view, but we can't do that with Java because we would have to change Java in different places to introduce that. But jOOQ is just DSL, like you have with Criteria API or with Query DSL. It's just SQL. We will see that in a minute. But that doesn't help a lot. So what jOOQ also has is a generator like the MetaModel API generator from JPA Hibernate. It uses, in that case, the database and generates Java classes. And it generates Java classes for all your database objects. So not only for tables or views, also for functions, stored procedures, user-defined types, array types, whatever you may have in your database. And for people who must use stored procedures in Java, you have to have a look at jOOQ, because jOOQ generates a Java class for your stored procedure, and you can call the stored procedure as you would call a regular Java class. So you will not notice any difference, and so it's very easy to use stored procedures, by the way, with that. But we don't use that for stored procedures. We just use it for our database access. Now maybe the question is, why jOOQ at all? The point is, if we have commands, we have maybe kind of minimal updates. So it depends how much business logic we have, right? So I know a lot of applications, they have literally no business logic. The only logic that these applications have are already covered in the UI mostly, or are covered in the database by not null constraints or check constraints or something like that, right? So a lot of them are just called CRUD, so create, read, update, and delete, and maybe for that we don't need business logic. But if you have business logic, also fine, it doesn't really matter. On the command side, it even doesn't matter if you would use a traditional stack like JPA Hibernate, for example. This would also work very fine, but with jOOQ we can create these minimal updates by our own. And on the other hand, for the query model, we have usually the request or the requirement that we must return nested structures. So we often have trees as a result. So in my example, we have an order, and the order has many items. So usually if we want to have the order, we also want to have the items. Now that's a problem if you use JPA, and if you want to return plain objects or plain old Java objects and not entities, because with entity you have this lazy loading problem probably, or Hibernate will create something like a Cartesian product and then use the Cartesian product to fill your objects. But with jOOQ we have something else. It's called multiset. Multiset is a so-called value constructor. I will introduce them in a minute, but the interesting part of that is that also the people that are standardizing SQL are talking about returning nested structure. Does anybody know how we could return nested structure from a SQL query? Any ideas? Yes? Exactly. So all the databases today support JSON, either to store it, or you have JSON functionality to return JSON or to construct JSON in the result. So that's also the thing that jOOQ does behind the scene. It just creates a JSON query. You could also use XML, by the way. Then you could have done that already 30 years ago, because XML was very early supported by databases because it was hype back then. So let's have a look at the CQRS application then. So we covered the command side here. I don't go into that, but I will like to show you first of all the working of jOOQ. jOOQ is very well integrated also with Spring Boot. I use Spring Boot because usually I use Spring Boot with my customers, but you can also have that with Quarkus or Jakarta EE. It doesn't matter because jOOQ is not dependent on any framework. It just uses plain JDBC. But here we have, oh sorry, I'm in the wrong POM here. We also have a jOOQ starter for Spring Boot, so everything related to jOOQ will be auto-wired for you, so you can just use the TSL. And in my example, I use Flyway to do the migration and also to load the database demo data, and then I use Postgres and stuff with test containers. I don't want to go into that, but if you're interested in how test containers support together with Spring Boot works, then you can have a look at my code. That's quite sophisticated now. And then we have a look at the DB here. That's my database creation script. Now, the problem about the generation here is, where does jOOQ generate the classes from? So if you use this MetaModel API in combination with JPA, you have the entities. So it's based on the entity model. You will get this entity MetaModel that you can use to create type-safe queries. Here we need some database. So there are a bunch of options. You could directly use, for example, the DDL script here. So jOOQ will use the DDL script and create the MetaModel. The problem with that approach is that not every object is supported in that case. So if you have stored procedures, this will not work. So you need a database. So the better option, in my opinion, is using a database to generate that. And here in my case, I'm very lucky because I could choose my database. That's why I use Postgres, because Postgres, and we will see that, starts extremely fast. So if you must use Oracle database, for example, then it may take a while to start the database. Because I'm using test containers to start the database, apply the Flyway scripts, and then generate the MetaModel. And because this is a very common scenario, Siva from the test containers team decided to create a plugin. So we have here a plugin that's called Test Containers jOOQ CodeGen Maven plugin, a very long name, and it's supported by test containers or developed by test containers. It's pretty new, that's why we have version 0.03, but I would say they could do the version 1 right away because there are not a lot of additions that are currently missing. And here I use test containers to spin up a database. I tell them that I want to have the Postgres database, and then we have some configuration. So first of all, we have to define when this generation is happening. This is happening in the Maven phase, generate sources. By the way, there is also a Gradle plugin, not from test containers, but from jOOQ, that you can also use Gradle if you prefer that over Maven. In my case, I use Maven because then I can use this test containers plugin. And finally, I define the database type. I can also set the image that should be used. In that case, it just takes latest. That's probably not the version that we want. We want to specify the version because other than that, latest, when the latest tag changes, we probably get another database version that we may not want. And then we have flyway, but because the flyway scripts are already at the default location, we don't have to define anything, that just runs. And then we have the jOOQ generator, and there we can configure a lot of things. That's just a minimal set, so we define which input schema we want to have to generate the objects. We can exclude something with the regex. Here I exclude the flyway schema history table because I don't want to use that. And finally I define a package name. That's it. And what's happened is if I run compile, for example, we will see that this is starting. So it starts Postgres Docker content. It's so fast. I have to stop that. Where we are. That's jOOQ. Here it starts in a bit more than a second. And then flyway runs. That is the red-ish log. And then the jOOQ generator is accessing the database here at the random port that has containers generated. And now jOOQ is introspecting the database and trying to find database objects. And finally it found the database object, so it found like 5 tables, one was excluded, and we also have sequences, so it uses that, and that's it. And what we have now is a meta model. So if we have a look here at, let's do a refresh. I'm in the wrong project, thank you. Here we have, first of all, some default information about the schema, about the tables and sequences, and then we get for each table we get a class. And this looks quite similar to other meta models from Query DSL or for JPA. We get constants that we can use then to make it type safe. And then we have like types like a table field or with the type and also with the information. We also get the information about the SQL type. We see that it's a primary key, for example, and here in the blank we will have comments if you add comments to the database. And in that scenario I will do that because like this you would also see the comments then in the Java code from the database. So what can we do with that? Let's have a look at the order service. Here we see that we can inject the DSL context. So that's the base interface that we need to execute our SQL. And then we have SQL statements, right? So this is the jOOQ DSL. It's fully fluent. And then we have this meta model, customer ID, for example. And that's it. And the idea about the meta model is if you change the database, for example, you rename the ID from ID to customer ID, your code will no longer compile. So we will not have a failing test if you have tests, or a failing production if you don't have tests. You will see that immediately in the code. And also based on the DSL that you use, you can't write invalid SQL. So you have like type safe and also change friendly way of writing SQL statements. Right.
These errors are also generated by JQRS.
Yep. Exactly. Now that's for writing. For writing, there is also something like a record. So jOOQ generates, in that case, for example, let's have a look, a purchase order record. Or not a product, sorry, a purchase order record here. This extends updatable record impl. That is something like an active record pattern. Maybe you've heard about the active record pattern. Ruby on Rails, for example, uses that pattern to access the database. Here it's just used to store data. So you get more or less a one-to-one representation of your database row, and you can use that to create a new one or to update an existing one. So if you do a query and don't specify anything else, you get the record back, you can change that and store it. So it's kind of an active record, but with a slightly difference to like JPA entities, you don't have any relationships. The only thing that will be mapped are the foreign keys, so you have to take care about the foreign key mapping by yourself. Now that's more or less straightforward thing, but let's go to the query side. First of all, let's run the application right here. It takes a while to start because it creates a new test container and it adapts or it executes all the flyway scripts. And now we can do the same GET request, but this time with the CQRS version, like this. And this still takes 1.5 seconds. That's not good, right? That's way too slow. But we also get back, I don't know how many rows at the end. We get way too much data, but it's not optimized. We don't have any indexes or stuff, so that just happens. But the interesting thing is we just get one SQL statement, right? And here we can see the SQL statement. Just to give you an idea, we have like the information from the purchase order, we have customer information, and then we have nested elements, and here you see the JSON functionality that is used to construct that. And the result that we get here is some data like the order ID and order date is a plain column. Then we get the first element nested, the customer, that's kind of a JSON structure, and then we get the order items also as nested structure in the multiset. That's how this works. And now we want to have a look how we have to write that. Where we are, sorry, wrong side. So we have the order query controller, and this is calling find orders in the repository. And here we see a very long SQL statement. So this statement, this statement is nested. So we first select the order, then we can the one-to-one relationship or the end-to-one relationship from purchase order to customer. Here we see something that jOOQ is able to generate. It has this possibility to an implicit join, like you do when you use JPA query language, for example. So if it's a one-to-one relationship, you can directly navigate to the attributes. That's the same that I can do here with this to-one relationship, but this doesn't work with the many relationship with the order items. So I use here this multiset operator to do a subselect that reads the order items, and it also nests then the product information. And finally I can map that, so I have various layers of mapping, and finally what I get back is our purchase orders in records in nested orders with customer order items and so on. And this just takes one query. Now the question is if this is really faster than what Hibernate is doing. The difference is here we load the minimal data with that query, and Hibernate will create a Cartesian product and load way more data for doing the same if we use entity graph, for example, or join fetch, and this could even be a bit faster. The point is how fast is fast, or how fast must it be. So that is something that you have to figure out, but other than that it's very handy because you can directly return this kind of data. So to conclude, for the first part, separating content queries really helps us in the current project to understand the application. Just before we had REST APIs and something we were calling this and get data back. The data was usually stored in a reactive store, then manipulated and sent back to the server. Now we really have these commands, so we see where a status is updated, for example, or something is deleted. That's very better visible and understandable. We avoid this under and over fetching because we really just send and consume the data we need for the particular functionality in the UI. And we even are more or less getting rid of map struct. So because we don't need the mapping is also already done by jOOQ in the reading or in the query side, so we can remove that code as well. And if we like to, we could even add an event-driven approach. So if the commands are successful, we could create a business event out of it and then use it in event store or publish it to a event stream like Kafka and consume it from there. That's it from my side. Are there any questions? So let's have a look in the app. And here we have 2 questions. Yes, the GitHub URL is, let's see, this one. And Quarkus has an extension for jOOQ. Yes. So we can jOOQ also use with Quarkus. You can also use jOOQ with Micronaut. There is also an extension for that. Any other questions? Okay, then thanks a lot for coming.